During the second lecture, we went into how more rational models of human decision making fail to account for certain patterns in human behavior. I mentioned how more descriptive models of decision making, like prospect theory, could better account for those decision making patterns. And I'm going to explain prospect theory and the most two important aspects of prospect theory using an example which partly was also used during the second lecture, but I'm going to into that in more depth for this video. So ideally, as a pple decision maker in the future, you would like to be able to predict human behavior. You'd like to model human decision making and human thinking. So if you offer a person, in this case Mr. Jones, or mathematically a bright citizen who strives to be as rational as possible in every situation, a ticket to lottery costing $1, and he has a possibility of one chance in 1 million to win $1 million. What could we predict him? What would he be likely to do given what we know about human decision making? So please excuse the elevator music, but I put it in there because people tend to get a bit confused when parts of the video don't contain narration. And I thought, well, you can read it in your own time on the screen, and I thought you'd prefer not hearing my voice for a change. So that's why I put in the, well, terrible 19th theme show music, which was included with the software package I'm using. So the question is, how can we better explain that Mr. Jones, in this case, chooses to buy a lottery ticket? And we have to look at, as we did during the second lecture, at the difference between subjective and objective probabilities. So instead of multiplying the objective probabilities by objective values, he probably multiplies the subjective probability by subjective values. And the objective probability isn't transferred one-to-one to subjective probability, so we don't weigh objective probabilities as we should weigh them given those objective probabilities, but we tend to overweigh very small odds. So if you have a very small odds of winning something, we tend to view that chance subjectively as bigger than it actually is. So we're oversensitive, if you will, for very small chances of winning something, which would explain why people are actually interested in joining or buying lottery tickets. It would also explain the following. In this case, we can have a look at two different ways of framing the same option. So we should expect that people make the same choices in both options. So you have either a probability of 0.5 of winning 200 euros or of a certainty of winning 100 euros. Or you have the same chances only of losing 200 versus 100 euros. And what you see is that people actually show risk aversion in the first frame and risk seeking behavior in the second frame. And we can explain that by the concept of diminishing sensitivity. This is a reversal in preference, which you couldn't expect under the rational model, but which we can explain using prospect theory. But before that, we're going to have a look at another part of prospect theory using a different example, namely the Allais paradox. This is what became known as the Allais paradox. It's paradoxical because, well, if you take a look at it, the reversal in preference that people have is very strange. So if people prefer 1A over 1B, it doesn't really make sense from an economics point of view, because the expected value of option B is higher by 0.39 million over option 1A, which is strange in and of itself, because you would expect people to prefer the option which gives them the most money. But economists would say, we're not talking about money, we have to talk about utility, and we can't make any assumptions about what people actually prefer. We have to go by their revealed preference, if you will. So if people indicate that they prefer option B over option A in the first lottery, that would mean that they don't like money that much, so they prefer to have less money than they would like to have more money, which is okay. So from that preference which I indicate in the first lottery, we would assume that it reveals preference for less money over more money. You could also do the same with bananas. I have the Allais paradox framed as a choice between a banana lottery, for example. And if you go to an alien planet and you hold a banana lottery and you don't know anything about the people living there, and they choose option A, which gives them less bananas, you would assume that they don't like bananas very much. And it becomes strange when we go to experiment 2, because there they do prefer the option which gives them the most money, or bananas, if you will. And this is what makes it paradoxical. Not necessarily that people prefer the option with less money, which gives them less money, expected value, in the first experiment, but that they indicate a certain preference, that they indicate by the preference that option A has a higher utility than option B, and that then the preference reverses. And we can explain that using classical models of decision making. And that failure of the classical model was the main reason that people started to questioning their assumptions about how people weigh objective probabilities and how they see objective values subjectively. So first we're going to look at the last part of the calculation, so the objective values versus the subjective values. How do we translate objective value to subjective values? And we should know by now that it doesn't take place in a linear version, in the sense that objective value of 2 units, for example, would translate to a subjective valuation of 2 units by the decision maker, but something else takes place, which you can see in this by now famous graph of prospect theory. And you should be able to at least describe 3 parts of this graph. So you should know that this is a descriptive model of choice versus a normative model, which we've been discussing before. It's a description of how people actually appear to make decisions instead of how they should make decisions given a specific benchmark of rationality, which we can use to better explain apparently irrational patterns of behavior. So important here, first of all, is that people make or decide on different prospects based on relative to a reference point. So it's not based on the absolute value you would attain if you make a certain choice, but it's related to your current status in relation to that goal. For example, how many money you now have, and related to how many money you would have or would lose if you make a certain decision. And everything you evaluate is in reference to that reference point, is relative to that reference point. The second and more important part is diminishing sensitivity, which we talked about during the lecture. We're increasingly less sensitive to further increases in winnings or losses, which explains the curve of the graphs and how it differs from a purely linear relationship, and which would explain how we are risk averse when it comes to considering different winnings, and how we are actually risk seeking when it comes to considering different losses, as I explained earlier in this video. And the third part of the graph, which is important, which you should study using the book, is the difference in steepness of the
relationship when it concerns losses compared to when it concerns winnings. We are more sensitive to losses than we are to the prospect of winning things. So if I would give you $100, you would say, give that a subjective value of, I don't know, 2 units of happiness. And if I would ask you to consider the loss of $100, starting from the same neutral reference point in this case, then you would find that, well, more negative than 2 units of non-happiness, for example, which is a bit of a convoluted example, but the loss of the same amount of money decreases your happiness, or you find more aversive, than you find the increase of the same amount of money positive, or evaluate that positively. Using these assumptions from prospect theory, you can better explain how people weigh different options when they make decisions. So they don't weigh value objectively, but they translate it to subjective values in which they are more loss averse. So they're more averse of losing things than they are eager to win the same things. And diminishing sensitivity allows us to explain why people are risk averse and risk seeking, and how the framing of the same problem would influence the decisions that they would make. The second part, or second graph, which is relevant in better understanding how actual decision making can be better described if we differ from the standard rational model, which came back in the video earlier as well and during the lectures. So I'm going through it a bit quickly. The first part of this graph, which describes the relationship between objective probabilities and subjective probabilities, or decision weights. And you can see in the first part that people are actually oversensitive to initial increases in objective probability. So they overweigh the small chances of winning, for example, in a lottery. And the second part is that people are regressive, which means that people are increasingly less sensitive to further increases in probability around the midpoint of the scale, which would mean that a difference in 40 or 50% chance of winning something doesn't play a huge part, or doesn't make a huge difference in our considering different options. So we would give you the option A, you have a 40% chance of winning, or B, you have a 50% chance of winning. I wouldn't see a huge difference in preference, because you're not really sensitive to those small changes in probability around the midpoint of the scale. And the third part is that we're actually become more sensitive as the probability increases 100%, reaches 100%. We prefer certain winnings over some chance of losing things, for example. So we prefer a 100% chance of winning something over a 95% chance of winning something more, for example, because we prefer certainty over uncertainty. So please study carefully these 3 points related to this graph, which is described in the book as well, and these 3 parts of the graph related to value, which should help you think about how the ideal model of multiplying objective probabilities by objective value is translated to another calculation, which is described by prospect theory, in which decision weights are multiplied by subjective value. Good luck.